In this example, we are going to write a cost function for this rectangular garden. Let me read the problem. It says a property owner wants to fence a garden plot adjacent to a road. So this is the road. Okay. As shown in the figure. The fencing next to the door must be sturdier and cost $5 per foot. So if I look at the picture, the fencing next to the road is this, and just to build this fence, the cost is going to be $5 per foot. But the other sides of the fencing is just $3 per foot. And the other information given is the garden's total area is going to be 1,200 feet squared. Okay, so coming back to the picture, I have a side which is the width of the rectangle, which is the same on either side, right? So to construct this, it's going to be $3 per foot. To construct this, it's going to be $3 per foot. And also to construct the top, which is the same length as my bottom side X, this is also going to be $3 per foot. Okay, so now I'm going to write the cost function. So before I even start the cost function, the first thing we have to do is to find width in terms of X. So the first step here is I need to find the width of the rectangle in terms of X. And right now I'm going to call it W, okay? The information I have here is the area of the garden, which is 1,200 feet squared. So A is equal to 1,200 feet squared. I know area of a rectangle is length times width. So A is equal to length is X and width is W in my equation, and the area given is this is equal to 1,200. So from here I can write width is equal to 1,200 over X feet. So this is going to be the width, and the width is going to be the same on this side, so I will have the same width on this side too. Okay, now to write the cost function, the cost to construct like 1 foot is $5 for the fence along the road. Therefore, if I have X foot along the fence along the roadside, then the cost to construct that side is going to be $5 times X. Plus, if I go to the top portion of it over here, this is another X, so it's going to be $3 per X. So 5 plus 3, 5X plus 3X. Plus, now I need to look at the width, which is, I know the width is, the length of the width is 1,200 over X times, X feet. But I have two of those, right? So 2 times 1,200 over X times the price, which is 3. Okay, so the cost is C of X equals 5 plus 3 is 8X plus, we multiply the numerator, it would be 3 times 1,200 is 3,600, that times 2 would be 7,200. So it's 7,200 divided by X. And yes, this is the answer for your section A. Write X as, okay, yes, this is the answer for A. So my cost function C of X equals 8X plus 7,200 over X. Okay, So part A is over. Now to part B, find the dimensions, find the garden's dimensions that minimizes the cost of fencing, So when you have these problems, which you will be seeing over and over again in the word problem section, you take the cost function that you created, which is c of x is 8x plus 7200 over x, and graph it. And I think we already talked about this. The dependent variable is the cost along the y-axis. Independent variable is x, which in this case is the length of the rectangle. Okay, and I'm going to graph it. And since I'm talking about a word problem, I'm not worried about what is happening on the negative x-axis and negative y-axis. Therefore, I'm going to keep my origin 0, 0 here. X minimum 0, x maximum 0. Let me put this graph on the calculator. Y equals, I'm going to put 8x plus 7200 over x. Okay, close parentheses. Keeping the window x minimum 0, I'm going to keep y minimum 0 right now. And then I'm going to keep y maximum 10, just so that you can see that what will happen if I use the standard viewing window. Nothing. So it looks like the graph is there, but it's not in the visible range. So one of the things you can do is use zoom fit and then adjust the graph accordingly. So I do see the portion of the graph, and it's a little bit more clear if I can see the minimum point a little bit more carefully, right? So I'm going to change my window a little bit. Again, this is after playing around, I figured this out. So you need to do some practice. Instead of 10, I'm going to call it 100. So let me see a little bit more on the x-axis. And the y-axis, I'm still going to keep my y minimum 0. But the y maximum, I'm going to probably change it to 1000 and see what happens. Okay, so this graph is a little bit more clear. For me, where it's saying the graph is coming down and then increasing. So it looks like there is a minimum point. Now, if I want to make it a little bit more better, I can, where I can bring down my graph a little bit more, I'm going to shift this y minimum value, maybe increase it to probably, instead of calling it, 0, let me call it like say 200. That's a little bit more better. So now what the question here is asking, find the garden's dimension, and to find the x value. So let me sketch what I'm seeing approximately here. So it looks like there is a point here where my x is minimum. So this is what I'm going to look for, and that will give me the length of the rectangle. So how do I find that? Using my calculator. Hit second, do not use trace. Okay, so hit second, calc. Sorry, I think I did. One more time. Second, calc. And when you do that, you will come to a screen here. I'm going to look for minimum because I'm looking for the minimum point. Enter. You see the cursor here. Use your left arrow. Bring it to the left side of the minimum point. Somewhere to the left, closer to the minimum point. Enter. Then right bound, bring it to the right side of the point. It looks like it's increasing, right? It's starting to increase. Enter. Enter again, and that will give me the minimum value. So see, the minimum x value is 30. So I'm seeing x is equal to 30 from the graph, and I don't want the y value. It's just, if it's asking what was the minimum cost, then the y value, which is $480. But here the question is asking for B, what is the dimension? So at x equals 30 feet, which means if I keep this length 30 feet, then correspondingly the y length would change, which would be taking this 30 and plugging it into the equation. W is equal to 1200 over 30 to get the width, which is 40 feet. So according to this second part, if you keep your length as 30 feet and your width is 40 feet, then you can keep the cost to be the minimum for making this fence. That's what this information is giving me. Okay, so again, to find the x value, find it from the graph. Find what the minimum x value is from the graph. Take this x value, plug it into the W equation that you made to find the y value, or the W value, or the width of the rectangle. So 30 feet is the length of the rectangle and 40 feet is the width of the rectangle. Okay, and that is what part B is asking. So for part C, the question is, if the owner has at most $500 to spend. So at the most, maximum they have $500 to spend. Find the range. Find the range of lengths he can fence along the road. So technically they want to know only this side, which is x. Yes, if this length and that length are the same, but if you find x, that will cover my question here, right? If the owner has at the most, so the cost the owner has in hand is only $500. And we have a cost function, c of x equals 8x plus 7,200 over x. So if I have to do the long way, then I'll have to plug in the value for c over here, and then I have to solve for x. That's what I have to do by hand. But there is another way of doing this problem easily. What you can do is take your calculator, and since we already have the graph here, you can go into y equals, and now graph the constant function. Just put y2 is equal to 500. Okay. Now if you put that, I know that y equals a constant is going to be a horizontal line. So if I see on my graph, I will see a horizontal line. Now you see the graph is intersecting at 2 points on the graph. So, but it's not very clearly visible, right? So it just looks like it's too close. So I need to expand it. So let me go and change my y minimum. Let that be a thing. Then let this be probably 60. And let me see if I can bring this to 300. And maybe the top to probably 800, just so that I can see the graph a little bit more clear. I don't know if that's helping me much. I'll have to shift this up, so I have to pull this thing down. Let me change my, let me keep this 60 or 70 maybe, and I keep my y minimum probably 0. Is that going to help? Let me see. No, I don't think so. No, this is not helping either. So now I'm changing. Oh, you know what I can do? Let me change the scale. So let me change, keep this 10 and keep this 800. That's fine. Now I'm going to change my y scales to say probably 20, and my, that's fine. Okay, graph. No, this is not helping me. Okay, so I have to go back to my window again. I can still see the graph, but I think it would be nicer if I can see a little bit more deeper view. And then go y minimum 10. No. Y minimum, oh, I keep it at 10. That's a very small value, so probably 100. And y maximum can be 800. But let me go in terms of 50. Okay, I think that's better enough. But okay, if you don't want, oh, another option that is there. I can just go closer to it and zoom into. I didn't think about it. Zoom in. Okay, so here I see the one intersection, and then I'll go to the other one. Okay, so this is the point I wanted to see, the intersection of the graph. So I need to know where the graph is intersecting, and then I will shift to the left to see the other point. Okay, so to find that, hit second, trace again, and now you're going to pick the number 5, which is intersect. And when I click enter, see, this is the first graph, y1, and it's blue, right? Bring your cursor closer to the point that you think the intersection is, and that's one of the intersection points. When you come too close to it, just hit enter, and automatically the cursor will shift on the second line. So it's on the second line, and you can see that second curve. So the question mark means they're asking you to confirm that is the second curve, and yes it is. So click enter again, enter one more time, and it will give you this point. So this rightmost intersection point is 40. So I'm having the rightmost intersection point of x equals 40. Now I want to see what the leftmost point is. So let me zoom out again. Now I'm going to use the other point and zoom in. So now I want this point. So I'm going to go closer to that point to zoom in. And I need to look for this intersection point. So I go second, trace again, intersect, enter, bring it closer to the point you think the intersection is, enter, and it's closer to it's on the second curve but closer to the intersection point, enter again, and that'll give you this point. So the leftmost intersection point is x equals 22.5. So what this is telling you is, if the range of the length is between 22.5 and 40, then it's okay because you have just $500 to spend. Okay, so since it's the range, it's all these x values, so I have to list all the values from 22.5 all the way up to 40. Right, if you think of a number line, it's from 22.5 all the way up to 40. So to represent this, I need a interval notation, and this is the interval notation for it, and that will be the answer for the third section. Bracket 22.5 comma 40 bracket.